Hello, Assalamualaikum and hi. We are from Group 8. Today, we want to present our assignment to recycle material classification by using convolutional neural network, CNN. First of all, we want to thanks to our lecturer, Dr. Ain binti Nazari, for giving us chance to complete this assignment too. Okay, for group member, first, Abdul Rahman Muhammad Sokri. My metric number is DE180017. Second member is Muhammad Shamsuri. Say hi.
Hi, my name is Muhammad Shamsuri bin Kamaruddin. My metric number is DE180087.
For the third member, we have Muhammad Zaihan.
Hi, my name is Muhammad Zain Amni bin Muhammad Zani. My number metric is DE180035.
Okay, next we go to the introduction. For introduction, a convolutional neural network CNN is a type of deep neural network used to evaluate visual imagery in deep learning. Based on the shared weight architecture of the convolution kernel, or filter that slide along input features and give translation equivalent response known as feature maps. They are also known as shift invariant or space invariant artificial neural networks. In this report, we focus on recyclable material classification by using convolutional neural network. Once this determination has been made, we then focus on the ability to distinguish the recyclable item. In this report effort, we trained and tested convolutional neural network to test recognition accuracy. The goal is to improve the environmental and ecological state of the society. Next.
So I will be continue for our presentation about methodology. So the CNN is the most standard method of the neutral system used for the problem in image agreement. The first is a deep and the second is the wide learning algorithm. So algorithm has two main process is convolution process and sampling process. So CNN is deep learning algorithm with take and input image. It is reduce the image into a from which is easy to process without losing feature. In this project, we have two tasks given. For the first task is classification process has carried out by CNN model. And for task two is the classification process was carried out by mean of CNN model with a transfer learning approach. Moreover, to design and the simulation convolution neural network CNN model was use Google Colab software. So I will continue about our result task. For task one, I firstly I go to my Google Drive. I create one folder to our project. So step one, connect to Google Drive. So we run this and we get connect the Google Drive. So step two, feeding dataset directory. So this is for we set link for our Google Drive and next create a train validation data directory. So we get the result. Can train length is 156 and pet train length is 310. Can val length 77 and pet val length is 133. So this is what we want to import our picture. Go to use this coding. So step for construction the CNN model. So this is our coding and we get the result. This. Like this, we go to make polling and convert 2D and make polling 2D. So step 5 is pre-process the input data. We set by batch size is 20, so we get the result label batch space is 20. So for the step 6, we start the training process and we try run. I don't run because we have the already run. So I run. It have 10 10 8 push. So after we run, we get the our result higher is 0.9857 at val accurate. So lastly, we go to step 7, plot the outcome. So this is our graph. We get like this. Okay, I pass to my friend Abdul Rahman to continue.
Okay, next for my part, this is task 1 recycle with new image. Okay, for the first step, we need to connect to Google Drive. Okay, after we connect to Google Drive, we go to step 2, feed data set directory, which is data from Google Drive is feed to this Google Colab. Then we have step 3. For step 3, we create train and validation data directory. As we can see, we import the data like train data, validation data, and this is new campaign is the new data, which is the image that we capture. As we can see the result, the can train length is 156, pet train length 310, can validation length is 77, pet validation length is 133, and for the new image is 9. Okay, we go to next coding, which is we use the TensorFlow program, and next we go to step 4, which is construct the CNN model. Okay, for construct the CNN model, we got the layer type, output shape, and also the parameter. As we can see, this is our layer type, output shape, and parameter. Okay, next we go to step 5, which is pre-process the input data. Okay, in this pre-process the input data, we go down, we found the 466 image belong to 2 classes, found 210 image belong to 2 classes, database shape is 20, 150, 153, and 3, and the last label base shape is 20. Okay, for the step 6 is we start the training process. As we can see in this training process, we do the push is 10, and in this training process we can get the validation accuracy. So we take the very more accurate validation accuracy, which is 0.9619. That's mean 96%. Okay. 7. Step 7. Now we go to plot the outcome. Okay. In this coding, first we import from the step C, and then we get the plotting. Now we see the plotting. Okay, as we can see, the validation accuracy is at 0.69. Okay, next we go to step 8. Okay, step 8 is fit sample image to observe which pet or can is dominant. Okay, for the first coding, we have pad and can stay same distance from the camera screen. Okay, this image is 100% can and 100% pad. Okay, next we display the image. Okay, we can see the image is displayed. And for the second is we do for can stay and pad move further backward, which is move further backward, which is 10 to 15 centimeter. Okay, this image is 100% can and 100% pad. Okay, next is the display image, which is the pad is furthermore to backward. Okay, then we have pad stay and can move further background. Okay, for this we have image is 100% can and also 100% pad. And the last one is the display image of the can furthermore background. Okay, that's from me. I will pass to my friend.
Okay, I will demonstrate about the task 2, the second task. Actually, there are 7 steps are similar with the previous model that my group mate simulate. Okay, the first step is to connect the Google Drive account with Google Colab by using a link given. Okay, so the purpose of this step is to fit a data set in step 2 for Google Collaboratory can access folder in Google Drive. Okay, the third step is to create train and validation data directory. Okay, for this step, it requires a path directory from the folder that has a picture for train and validation, which is the picture is a can and pet portal. Okay, next is step 4. For this step, it will construct a pre-trained model with VGG. So as a result, it will generate a model that consists of layer, output shape, and parameter for model VGG, as we can see. Okay, next is step 5. Okay, for the step 5, it is a pre-process for the input data that it will rescale all image by 1/255 and has a 3 method flow, which is the picture is from a target directory and will be resized to 150 times 150. So as a result, it will generate a data bash. It will generate a data bash and label bash shared for the found image in a class mode. Okay, the second last is step 6, which is a start training process. Okay, for the start training process, it will start the training process with a step per epoch. Okay, so here the step per epoch is 10 and epoch is 10 and the validation step is 10. Okay, to select accuracy, we refer from the validation accuracy. From the validation accuracy, we can see 1, and then from the validation accuracy 1, okay, we can select the accuracy is 0.9 seed, and the loss is 0.13. If you time 100, we get the percentage, which is 96%, and the loss is 1%. Okay, the last step is step 7. Okay, for the step 7 is the plot outcome. Okay, for this coding, you will plot a graph for epoch versus with training and validation accuracy. Okay, this is my graph after I run the coding. Okay, as you can see in the graph, Okay, the validation line accuracy, we pick the highest validation accuracy, and then we get the dot at training accuracy at 0.96. Okay, also the same with training and validation loss. We just pick the value at validation loss, the line graph, the highest, and then we get the training loss is 1, 0.1. Okay, net is the second model, which is ResNet. So for the second model, it also same with the others. Okay, the second selector model, it requires same state with VGG and CNN, but it only different with in programming, as we can see. Okay, so we can go through go to step 6 to see the. Okay, we go to step 6. We can see from the training process, we get the validation accuracy is 0.65. Okay, to pick the validation, to pick the accuracy, we just do same as before, as I explained at VGG model. Okay, so the step 7, plot the outcome. As we can see, the graph, okay. For the training and validation accuracy, the line graph, we pick the highest value, and the higher value is 0.65, and the training accuracy dot is 0.81, which is if you time with 100, you get the percentage. The validation accuracy is 64.5, the highest among the others, and then the accuracy is 81%. Okay. Okay, for conclusion, in conclusion, so by completing this project, we can explore more about the convolutional neural network and discover the architecture of VGG and ResNet model. Okay, firstly, CNN has an excellent capacity sequence, data analysis such as natural language process. So CNN consists of two basic operations, which is convolution and pooling. The convolution operation using multiple filters is able to extract feature from the dataset, through which their corresponding spatial information can be preserved. Okay, for VGG, VGG 16 is a 16 layer architecture with a pair of convolution layers, pooling layer, and at the end, fully connected layer. So VGG network is the idea of much deeper network and with much smaller filter. So for right now, it has model with 16 to 19 layer variant of VG16. So one key thing is that this model keep very small filter with 3x3 convolution all the way, which is basically the smallest convolution filter size that is looking at a little bit of the neighboring pixel. Okay, lastly for ResNet model, all convolutional layer apply the same convolutional window of size 3x3. So the number of filter increase following the depth of network from 64 to 512. So in all model, there is only one max pooling layer with pooling size 3x3, and strike of 2 is applied after the first layer. Therefore, the reducing the resolution of the input is significantly limited during the training process. So at the end of all model, the average pooling layer is applied to the replaced fully connected layers. Okay, that's all for me. Okay, thank you.